This is 4.3c part 3. So we're going to continue with the problem. Example number 4 now, we'll move on to that. We have a submarine that's submerged at a depth of 600 meters. It rises at a rate of 4 meters per second. And we need to write a linear relation that shows the depth of the submarine and the number of seconds it's been rising. So what that basically means is we have, so here's some water, and here's our submarine. And the submarine is currently 600 meters below the water. And our submarine is rising as well. And so we want to write a linear relation of the form y is equal to mx plus b. Now, in this case, we know our position, our start position is 600 meters. Now that's like our flat feet. That's like our B over here. The thing is, though, that we're below the surface of the water. So we're going to make that a negative number. We're going to consider the surface of the water being position 0. And when you go below, that'll be position negative 600. So when we're writing this equation, we're going to have to define our variables first. So y will be, let y represent the depth, meaning how deep the submarine is. And we'll do depth in meters. And let x represent the amount of time that's gone by, because our ship is rising at a rate of 4 meters per second. So we're going up 4 meters every second. So let x represent time in seconds. And so our equation would look something like this. The depth is going to be y. Now I could have chosen a different letter. I could have chosen d instead. And then for time, I could have chosen t. It doesn't really matter as long as I define the variables properly. But our depth y is going to be equal to 4x, because we're going up 4 meters every second, so x is the number of seconds that go by, minus 600. Because we start off 600 below the water, which is why it's negative in that case. So now in part B, our question is, write an equation you must solve to determine when the submarine will reach the depth of 486 meters. This 486 meters represents our depth. So let y equal, now we have to be careful here because we're still below the surface of the water. We're just less deep. But because we're below the surface of the water, we're still going to be negative 486. So basically we want to know at what point will we get to, let's say, over here, negative 486. So what we're going to do is we're going to put that into our equation that we came up with. We're going to write negative 486 is equal to 4x minus 600. And now we're simply going to solve for x, our time, by using inverse operations and isolating for the variable. So we'll do negative 486 plus 600 is equal to 4x minus 600. And the reason I did plus 600 on the other side is because I have to do plus 600 here to get rid of the 600. And so now, minus 486 plus 600 is 114. Minus 600 plus 600 is 0, so we have 4x here. And now we can divide both sides by 4. The 4's over here cancel out because you have 4 on the numerator and the denominator. And so we get x is equal to 114 over 4. And you can actually simplify that a bit more. You can get x is equal to 57 over 2. Which, if you had to write in decimals, would be 28.5 seconds. So we've solved the equation. I really just did part C all in one here. I should have done part C was really list the inverse operations that we're going to be using. So we had done an addition and a division. And then over here is where I would have done the solving, which I did up here. So 28.5 seconds. So what I'm going to do is write a therefore statement. Therefore, the sub takes 28.5 seconds to reach 486 meters. And so that's our therefore statement. The last part of this question requires you to verify your solution. So we're going to do that using a left side, right side table. So we have left side, right side. We know that y is equal to 4x minus 600. We know in this question that y was negative 486. And we found that x would be equal to 28.5, so we're going to replace that x by 28.5 in there. Minus 600. So minus 486, let's rewrite that here. Now you can go into your calculator and put 4 times 28.5. And we get 114 minus 600. So we get minus 486 here still. And if you do 114 minus 600, you get minus 486. So because the left side is equal to the right side, we know, therefore, we know that x is equal to 28.5 seconds is correct, is a correct solution. So that one required a little bit of thinking. To really solve this properly, a drawing would have helped you to understand the position of the submarine, the fact that it's located below the surface of the water that we defined as 0 meters, and we had to therefore put that our starting point was negative 600. That was our B. Our M is 4 because we're rising 4 meters for every second that go by. I'd like to extend a problem, so I'm going to extend this problem. How long would it take for the submarine to reach the surface of the water? So you should pause the video and try that out. So back again to our extension question, asking how long would it take for the submarine to reach the surface of the water. Remember from our drawing we did earlier that we had said the surface of the water is basically 0 meters, and the submarine is located at 600 meters below. So what this question is asking, basically, how long does it take before we get back up to the surface, which is 0 meters? So what we're saying is that y is equal to 0. So what you need to do is solve for the variable by replacing y by 0 and then finding out what x is at that point. And so we can do that. We'll do 0 plus 600 because I got rid of 600 from the right side is equal to 4x minus 600 plus 600. And we get 600 is equal to 4x. Then we can divide by 4 on both sides. And we get x is equal to 150 seconds. And then you can go and write your therefore statement, and you're done the question. So some of these questions do require a bit more thinking than others. They're not all as straightforward. That's why you need to understand the problem before you go ahead and write your equation. So think it through before you write your equation. Make sure you pay close attention to the signs. And then after you know your equation is well written, then you can go and solve for whatever we're asking you for. You can see your homework is listed here and in the course outline. Please make sure you attempt the problems and the notes before you go back to your homework. And then once you're done these problems, then you can go and try your homework.